Hello everyone. Today we're going to build off the scripting stuff that we learned last time. We're going to talk about how we actually access specific inputs and how we use those inputs to create certain behaviors. So let's take a look at some scripts. So I've got my reporter script from last time. I'm going to go ahead and make a new script today, and I'm going to add a new game object to hold on to the script just so we can get in the habit of having scripts attached to certain objects. I'm going to create a sphere. Again, it doesn't really matter what this object is. It's just going to be a place to plug in my script so that my script will run when the game is played. So let's talk a little bit about how we gather input in our script. So I'm going to go to Create. I'm going to go to C# script, and I'm going to change the name of this to input reader. Again, our script should reflect sort of what the script is intending to do. We should always change it from the default name. We should never just have it say new monobehavior script. But this one, input reader, is kind of vague. We're going to use it just to test different input elements. Okay, so let's open this guy up. So much like last time, we start with an input reader, which extends a monobehavior, and we have our start and update methods. So to understand how this is going to work, we need to think about how we want to handle our input. So one way of handling input, obviously, is to handle specific key presses. So let's talk about that first, because I think that's a little bit easier to grasp than some of the other modes of input that we're going to talk about. So when we talk about our input as it pertains to keys, we just need to call certain methods and use certain objects. So much like in Java, a lot of our information is going to come from objects that are already built into Unity. And that, in part, comes from the monobehavior class. So in our update code, we're not going to use start today because we don't really have anything to set up. But in our update code, we're going to use something that'll help us gather input from the user. So I'm going to leave the scripting basics here, but I'm going to add a new note, and this is called the input object. So the input object has some methods in it that allow us to figure out the given value of a input value. So the given value of any specific particular key or mouse movement or whatever. And it measures these in different ways. So the first thing that we want to do is deal with specific key codes. And to do that, we're going to need the key code object as well. So input has a method called getKey. GetKey returns true if the key is pressed. And to use getKey, we're going to use something called the key code object, which has variables for each keyboard key. So let's try it out. Now we know that we are going to get a result that is true or false, right? GetKey is going to return true if the key is pressed. So because of that, we need a variable to hold on to the result. So get whether, excuse me, and we'll just start with the Y key. Get whether Y is pressed. So to do that, we need a variable to hold on to. Our type for true or false in Unity, as we learned last time, is called a bool. It's not Boolean in this case, just bool. So I'm going to say bool is pressed equals input dot get key. And getKey needs a, and you can see that Visual Studio is being very helpful for me. It's saying input.getKey takes a key code, key, returns true while the user holds down the key identified by the key code enum parameter. So basically, it's saying checks the key. If the key is pressed, then it says yes, that is what I want. All right, input.getKey, and we will say key code dot, And then we have pretty much every key that we could imagine. I want the Y key, so I'm going to say Y. And then I close it off with a semicolon. So now if it's pressed, we want to do something with this, right? So we want to check the isPressed variable. So if the key is pressed, print a message. Key is pressed, print a message. Okay. If is pressed equals true, and I'm going to use the long form syntax for now, for those of us that just came from Intro to Computer Programming. But one little tip, remember that because isPressed is a Boolean variable, we can also write our conditionals like this. We can just say if isPressed, because isPressed will be true or false. So if it's true, it passes. If it's false, it fails. But in this case, I'm going to keep the long form and say if isPressed equals true. So if isPressed equals true, that means the key is held down. So I'm going to print user says yes, since the Y key is usually for yes. Okay, now if I've done this correctly, every time a frame executes, our script is going to check if the Y key has been pressed, and if it has, it's going to print this out every frame. So that means the longer I hold the Y key, the more times this is going to print. And before this will work, remember that we have to attach it to a game object. So I'm going to go to my sphere. I'm going to attach my script. Now, just so our console doesn't look really messy, I'm going to get rid of the reporter script. So I'm going to uncheck this so that our cube doesn't do a bunch of the stuff that it tried to do last time. And let's run this. So now when I play it, nothing's going to happen, right? Because it's going through, it's checking, and I haven't pressed the Y key. Now I'm going to press the Y key. And now user says yes over and over and over again. I'm going to let go, and it stops. Now, real quick, I want to see how quickly, if I just press it real fast. You can see that sometimes, oh, there we go. So you can see that when I press Y, that was because I was clicked out of the game. I was worried there for a second. So when I pressed Y, keep in mind how fast this is happening. I just quickly tapped the Y button, but it registered my tap for 4 frames of a second. So even though I only pressed it really fast, I was holding on to that Y key for 4/60ths of a second. So that's how often update is running. It's running super fast. Okay, so that is how we get a specific key. But sometimes getting a specific key isn't exactly what we want. Think about any first-person shooter game that you have played, right? Or really, actually, any game in general. It can be a platformer, any game that involves movement driven by the user. Most of those games allow you to configure what keys you want to do, or what you want each key to do. This doesn't work if we're checking for specific key codes, right? Like, let's say I want to use up, down, left, and right on the keyboard to move, but then I have a different user that wants to use W, A, S, and D. I'm going to have a lot of code that basically says if it's a W or if it's an up or whatever, and those things are going to have to change based on what the user selects. So instead, we have something called input axes, and these are more generic versions of our input. They're kind of an abstraction. So this is for key code. We also have input axis, and the input axis is independent of a specific key. In fact, it's set by us initially. So if we go into our Unity editor, and if we go to Edit, Project Settings, Input, we can see that we have something in our inspector called an Input Manager, and then we have different axes. These axes are meant to represent common interactions found in the Input Manager. For example, we have horizontal movement, we have vertical movement, we have action buttons, right? They call them fire because they're sort of thinking about a shooter, but the idea here is the action buttons. the x-axis on your mouse, the y-axis on your mouse, a jump button, scroll wheel, and then we have some alternate options for those. So let's just take this look at this first one called horizontal. Horizontal means our sideways movement. In a first-person shooter, this would be our strafing. We have the name of it, which is horizontal. We have a negative button. In this case, our negative button is left. What this means is, if we're holding left, it produces a negative value. So input axes return positive or negative values based on the direction of the pressed button. And really, this is kind of, get out of it. Let's get back there. Edit. Project settings, input. Really, this is dependent on whatever your personal preference is, right? So we are choosing left to be the negative direction. So negative in this case means that we are going to move this way, to the left. Whenever we are holding left, that means that the horizontal axis will return a negative number. If we're holding right, then it will return a positive number. We also have the Alt negative button, which is A, and the Alt positive button, which is D. So they've given us a couple of options here. Gravity, dead, and sensitivity, whoa, we're not too worried about that. Again, these are options that you can change to change how the movement feels. So if you find that your buttons are too sensitive, you're moving too much, you can change the sensitivity. If you want, you can change the gravity to affect how high jumping is and that kind of stuff. Our type here is a key or mouse button. We could change it to mouse movement or joystick axis, but in this case, horizontal axis we want to use keys for. The axis is the x-axis, and number pad, get motion from all joysticks. We're not worried about that. We're just going to leave that as is. But we can see that we can change how these axes work. All right, so let's actually put some of this to use. We're going to deal with just the horizontal axis for now, but what I'm going to show you, you guys are going to expand upon in class, and it all basically works the same way. So let's see how we actually get this axis. Keep in mind that these axes are going to return a negative number if the input is negative, and it's going to return a positive number if the input is positive. So in this case, we are going to get the value of the horizontal axis. If it's negative, print a message. If it's positive, print a message. So we're basically going to find out which direction you're heading, or which direction you want to go in. So get the value of the horizontal axis. So the horizontal axis, unlike our get key, returns a positive or negative number. Specifically, returns a positive or negative float. So we need to create a float variable. I'm going to say float horizontal equals, and then we're going to follow the same process. We want input from the input object. We're going to say input dot, I'm forgetting something, get axis. Get axis. And then we need to provide as a string the name of the axis. So we have to be very, very careful here. This is an opportunity for us to introduce a little bit of error. Remember that our axis has a name property. The string that we pass to our input manager has to be this string exactly. So in this case, it's horizontal with a capital H. Get axis horizontal. And I'm going to update my notes here. So the method is called get input dot get axis. In this case, it was input dot get key. So if it's negative, print a message. Easy enough. If horizontal is less than 0, print negative movement. Now, notice that we can't say else here, because if we said else, that would include 0. And we don't want to print anything when horizontal is 0, because horizontal being 0 means that the button is not being, neither of the buttons are being pressed. So if left nor right are being pressed, then the value of horizontal will be 0. So I'm going to say else if horizontal is greater than 0, horizontal is positive, print positive movement. Now I know you guys can't see my keyboard, so you're going to have to trust me on this. We're going to save our work. We're going to go back here. We're going to test what we did. So I'm going to clear this. I am going to hit play. And right now, nothing should happen because I'm not pressing anything. So I'm going to start by making sure my old code didn't break. So I'm going to press the Y key. And I get user says yes. Okay, brilliant. Now I'm going to press the left on my arrow keys, and we should see something happen. Interesting. Did I write my conditionals backwards? Horizontal greater than, or less than. All right, I've done something backwards here. Negative button is left, positive button is right. Let's check what happens if I press right. Interesting. So my horizontal axes values are backward, which doesn't make any sense because my things are mapped correctly. If horizontal is less than 0, all right, let's print out some values instead. We're going to change this a little bit. We're going to get to the bottom of this. If horizontal does not equal 0, we are going to print h value equals, and we are going to add in horizontal. Let's see what happens here. Stop our project. Start it again. And let's see, Y still works. Y works. Okay, we press left. And our H value is positive. We press right. Our H value is negative. Okay, I'm going to try pressing A and D and see what happens. We press A. Our H value is positive. We press D. Our H value is negative. Okay. So for some reason, these guys are backwards. Now, there's two ways that we could deal with this, right? The first thing that we could do is change these values. So if we wanted, if this wasn't behaving the way we'd expected it to, we could just change left and right. The easier thing to do, though, now that I've figured this out, the easier thing would just be to switch our conditionals. So if I undo here a few times, now that I know that Unity is interpreting my input backwards, easiest thing would be to just change my change it in my head, basically. So I could either continue to think of it as negative and change my signs, or I could just realize that these things are backwards and change them, or deal with it, right? Change it so that I'm looking for, if I'm expecting left movement, then I can change it so that left is positive instead of negative, right? There are several different ways I could fix it. Although it doesn't make sense as to why it is backwards. It's just something that I guess we will have to deal with. I'm going to save this as my main scene, so my work is saved. But that is basically how we handle input axes. And again, we can do this for any of these. So our vertical axis are the keys for up and down. We have fire, we have jump, which in this case is our positive button is space. We have no negative button for jump, right? When we jump, we just press space and we get a positive button. Now notice that nothing actually happens in the scene when I do these things, right? So if I hold left or right, I see the output, but I don't actually have anything happen. That's because if we want to actually move our shapes, we have to script the movement. Unity doesn't know what we want to do with these values. All Unity knows is that we're checking for them, right? It's up to us now to say, okay, if the horizontal value is negative, what do we want to have happen? So in here is where we would normally put our code to move the object. And we will talk about that very, very shortly. So the last thing that I want to show you is how we would get mouse input. So mouse input are things like getting the value of our mouse axes. And if we look at mouse X and mouse Y, we'll find that they're actually very, very similar. So the only thing about it is there's no negative button, there's no positive button. The difference is our type is mouse movement. So if our mouse is moving in the positive direction, then we would get a positive value from our getAxis method. So here, where we call getAxis horizontal, we would just call getAxis mouse X instead. And we notice that we only have mouse movement in two axes, right? X, and Y. So if we want to get diagonal mouse movement, we just have to check both, right? We would have to get the value of the mouse X in the vertical direction and the value of the value of mouse X, which would be our horizontal direction, and the value of mouse Y, which would be our vertical direction. So that's how we know we're going diagonal, is if they both have values. The last one, though, for getting mouse buttons, is input dot get mouse button down, and we pass it a number. We pass it 0 for left mouse button, 1 for right mouse button, and 3 for center mouse button. So again, all of this code works the same. It's just a matter of which axis we want and which values we are looking for. And I'm going to give you guys some tasks to complete with this in class to try to use some of these different axes values. But they all can follow the same example. Thanks for watching.